Today's episode of On Orbit is brought to you by AVL Technologies, a leading manufacturer of multiband and multi-orbit satellite communications ground terminals serving both government and commercial markets. With terminals ranging in size from 60 centimeters to 4.6 meters, AVL provides efficient, cost-effective solutions for voice, video, and data connectivity without the need for specialized training. AVL's innovative and visionary approach to engineering and design ensures the critical requirements of today's missions are met. For more information, please visit avltech.com. That's avltech.com. And now, on to our episode.
In this week's episode, I interview Beau Legeer, Director of Imagery and Remote Sensing at Esri. While Esri doesn't operate its own satellites, the company integrates commercial and government satellite data into its ArcGIS software offering, working to make satellite imagery accessible and user-friendly for its customers. Beau talks about how the barrier to entry to exploiting satellite imagery has dramatically decreased from his start in the industry when images were still processed on tape. And now, how advances in AI models and even business models and subscriptions are lowering that barrier to entry even further to allow for more widespread adoption of satellite imagery. You're listening to On Orbit, the podcast that asks, what's our future in space? Hi, Beau. Welcome to the On Orbit podcast.
Yeah, hi, Rachel.
Awesome. Excited to have you here. So, Esri, I know that Esri does not have its own satellites, but the company is still a really critical part of the commercial satellite imagery ecosystem and bringing that imagery to real life users. So wanted to have you on and talk more about how Esri works with commercial satellite imagery providers. So to get us started, just tell me a little bit about yourself and your role at Esri.
Yeah, sure. So really happy to be here. My name is Beau Legeer, and my title at Esri is the Director of Imaging and Remote Sensing Business Development. And what that means is that I lead a group of people whose charter is to demonstrate the value of imaging and remote sensing data sources from satellites, from aerial, pretty much from everything from space to ground, to demonstrate the value of those data inside of GIS workflows. Not only traditional mapping and projects, which has kind of been the lifeblood of the industry for however long it's been around, but also in kind of evolving mission-focused systems and GIS and location systems that are powered by Esri that solve a specific problem, such as land records or census or supply chain. So we work with a lot of Esri's existing customers, some new customers, and just show them why imagery can help them, can add value to their day-to-day work.
Can you talk to me just first of all, establishing, I'm familiar with ArcGIS, but really what it is and how much data is so I know that satellite imagery it's not the only source of data that's making up ArcGIS.
No, I mean, ArcGIS is a platform that just brings all sorts of data together with the variable that ties it all together is location. So most people use it to bring in feature data or other types of data that go on a map that describe attributes about a location, whether that's population or demographic data to data about the land and its use and its characteristics. Pretty much any type of data that can be associated with a location, such as parcel information and about your house or your business or your city or your government. That's the ArcGIS platform. It brings it all together in a location. Imagery and remotely sourced imagery, of course, has that locational context. So it's a natural fit. For many years, imagery was foundational. It was just kind of like the context behind the map. It was used to, if you're in a location, to actually see what's at the location, with the best sources coming from satellite collections or aerial collections. So the map was more than just vectors and lines and polygons. It was the actual picture of that scene. So that that's how imagery kind of got introduced to the GIS system. But over the years, people have seen that it's more than just foundation. It can also be a dynamic piece of information, one that can
Mhm.
describe and add new information that otherwise doesn't exist in the data sources they have access to. So that's, a lot of what we spend our time on is showing them how this dynamic piece of information can really add value.
Yeah, absolutely. So, talk to me about how Esri integrates commercial satellite data. I know you guys work with partners and
Yep.
bringing in that commercial data. Is it you're working with like just kind of, do you work with a ton of satellite companies? Is it just certain ones that you partner with? How does that work?
So we maintain a partner ecosystem. Within Esri, there's a large partner ecosystem, but specifically within imagery, we maintain a partner ecosystem of pretty much all of the commercial imagery providers for remotely sensed content. So those are partners like Maxar and Airbus, Black Sky Planet that are in space, amongst some others, but also aerial providers who provide higher resolution data sources from the air, focused on more localized or kind of state local use cases. So to people flying drones and driving imagery on cars as well. And they are the first kind of line of defense of how we bring in data into commercial data into ArcGIS. It's through them, and we make sure that we are compatible with their data formats, with their very unique metadata that they bring in, their kind of special characteristics of their data. We make sure we can bring it into the system and expose as much of the goodness of that data as we can, and then make it available for our users to exploit with the various tools in the system that we have. So that's kind of the first thing we do. But we also go deeper with some commercial providers where they've made their data available through services, through web services. So it's very straightforward to bring their data in and to bring in lots of their content, because a web service served from their platform into ours can serve a tremendous amount of content and bring in almost daily content, or allow you to go back in time to do forensic evaluation or time series analysis. So we do that. And then finally, we have a relationship with one of our partners, that a partner named Skywatch, that brokers content. So in other words, provides kind of a single interface where you can see almost all of the commercial ecosystem, hone in on time of interest, and then purchase data. And when that data comes in, it's automatically brought into the system through services. So we work at various levels of that integration, but the result is a usable product, a usable image product inside of ArcGIS that works with all of our tools.
Yeah. So are you trying to kind of take away some of that complexity for Esri's users where they can access it? It's all in, whatever format they need versus going to multiple different satellite providers.
Yes, definitely. And I'll just expand. It's not only the
Yeah.
complexity of the data, but the complexity sometimes of the purchase, and the license and all that. We're really trying to reduce all of those barriers, so that the users can really focus on getting their work done and not have to worry about, is it compatible with this, or can I read it, or am I looking at the bands in the right order, to get technical. They're we do our best to remove all those complexities, but also are trying to make it easy to actually acquire the content needed as well, so that people can bring in content when it's needed to either update their GIS, update their base map, whatever their workflow might be.
Yeah. What are some of the challenges that have been overcome there? Is that you're finding out what you need from your users and then also taking that back to the companies and figuring out like agreements that will and workflows that will make sense for everybody?
Yeah, I mean, a lot of the big challenges. I mean, there's challenges in, if people writing out different types of data formats. That has largely been overcome. The industry's come together and agreed upon some standards. That's helped a lot. Um, but for those that haven't, or are starting anew, we try to just be that middle ground. We can read it all and bring it in. Uh, but also we do go to the industry and we talk a lot about the making commercial imagery more pervasive and working on licensing terms that'll encourage adoption and use and trying to encourage them to create licensing models and business models that actually fit the use patterns. And that's a work in progress, but we're working together with our partners, with the industry, and the industry is been great. They're very respectful of the fact that we do have a lot of users using their content, so they for the most part kind of take note and listen and take feedback.
Yeah, absolutely. What are some of I know that there are millions of use cases for satellite data in ArcGIS. But just talk to me about some of the ways that Esri users are using satellite data in their work.
Yeah, they range from things that people have been doing a long time to some very novel use cases that we're seeing more recently as the market's expanded. I mean, so starting with kind of the long time use cases, one of the main things people use satellite imagery for is like land cover, uh, descriptions. It's satellite imagery is a very good source to kind of determine what is the use of the land. Is it urban? Is it agriculture? Is it forest? Is it built up or urban rural? And satellite data has the content that can allow you to actually build these classes, and those classes of land use fit very well into GIS workflows because they just come in as another layer that you can add on to other GIS layers and really get a good picture of what's going on in an area. The very classic use of imaging or remote sensing has always been change detection. Just is the land changing? How is it changing? How long has it been changing? And that requires, or that really thrives when you have satellite imagery that's consistently collected from government sources or commercial sources, because you can look at the same area and you could basically do some math and say, yes, I see major change, minor change from this to this. When you combine that with land use, you can say it changed from urban or rural to urban to something else. So those are the two classic use cases. And those are used across up and down various industries. Now, when you get very specific, um, state and local governments and national governments have always used it to monitor assets that they are responsible for, such as roads, such as sidewalks, and other like for government assets, to look to do things as basically as determine if maintenance is required or if there's compliance to regulations, such as state and local governments looking for compliance to ADA regulations on sidewalks or just damage. Does the sidewalk need to be repaired because there's cracks detected? This is where evolutions in artificial intelligence and AI and machine learning based workflows have really helped that out, because they've made those types of extractions of objects like cracks, sidewalks, and everything, made them more usable and approachable to a larger set of users. Because some of the users in state and local governments and utilities and even in like government customers, they're not trained as image scientists as much as they are in their own disciplines. And some of this traditionally required image science knowledge. Now with AI, it's really just the application of running a pre-trained model or building a model. And there's a lot of resources on how to do that. And what gets me most excited is that the use cases that are growing in the private sector with utilities, with commercial businesses and natural resource firms and engineering firms that are using imagery just to monitor and track and act upon the assets that make the most, or that they're most concerned about. So take architectural engineering and construction, where they're using drones and aircraft to monitor construction. Now, 10 years ago, it wasn't possible to do that because the satellites were not the pictures weren't good enough, they weren't frequent enough, and they were very expensive. With drones and some of the increase in sensor technologies from aircraft, you can do that almost on a weekly, monthly basis and track construction and look at the actual construction versus what was designed, the as built versus as designed. We've seen construction companies really embrace it, and engineering and architectural firms embrace that because it gives them a checkpoint, and it's really become approachable because of drones and some of the AI technologies.
Yeah.
So there's multiple use cases, but those are some of the things we're most excited about.
Yeah, definitely. With the advances in AI and the models that are able to do some of that scanning, so that you mentioned people in like state and local governments don't have to be experts in imagery. How recent has that change happened?
Um, I mean, the first models that started to seem to, to come out were like 4 or 5 years ago,
Hmm.
and but they were part of a more complex workflow of the user having to acquire a lot of imagery, label it, train a model, and then run that model and keep it up to date. What we're seeing in the last, I would say, 12 to 18 months is just a big acceleration of that technology, um, powered by some of the bigger players in the industry like Facebook and Google that are building these foundational models that are combining with large language models that are able to extract information from imagery just with text prompts. And that is really changing the game, and it's happening very fast. So, as an example, I would say about 12 to 18 months ago, uh, there was a release of a model called Segment Anything, which could take an image and just break it up into very distinguished segments and say, this is something, this is something, this is something. Um, then about 12 months ago, 6 to 12 months ago, that model was enhanced to so you could actually type, I want aircraft, and it would try to find the segments with aircraft in it. And it was very effective. And it's getting better and better. So we're seeing these advances very recently, and they're rapidly happening to the point where we're going to get to a point where we're going to be able to find almost anything if it exists in an image, basically with text prompts. And that leads on to the next thing that we're hoping happens is that, okay, if you can effectively extract almost anything from an image reliably, if it's in that image, how do you put that into workflows that are powered by agents, AI agents, and really kind of automate processes that people can then insert into their business systems or their government systems, where the imagery is being acted upon and being extracted, and the information is it's all happening behind the scenes. But what happens is just an updated map or an updated process in a business system powered by imagery. So we're really excited about that because that's what we always wanted imagery to be, is an essential element of a business or a government's operation.
Yeah, that's really interesting.
Yeah.
When I was at GeoInt in the spring, OpenAI had a keynote, and the speaker did a demo where it was using the reasoning model, and it wasn't satellite imagery, but she shared an image of it was an image of a rabbit, and the reasoning model was able to look at that image and figure out exactly where the picture had been taken by analyzing like the grass, the species of the rabbit. It was crazy to me how
Yeah,
much those models are able to do.
I would love to see that reasoning, get into the geospatial space and,
Hmm.
geo reasoning. So
Yeah.
reasoning with the geographic problem or context in mind. So if, and you could point a geo reasoning model at a situation and get more depth to, what more information about that situation, like point point a geo reasoning model at a train yard with oil tankers in it, and not only go beyond just the counts, just say, you know what, these counts mean that this upstream supply is challenged. or the impact on the downstream deliveries, which could then lead to a cost model, which could lead to this. I, that could potentially, with those type of reasoning models you're talking about, be derived from a single image with some other pieces of information that feed into a system that's all agentified. So it's an exciting time. I mean, that GeoInt example has applications way outside of just the rabbit.
Yeah. So that's a very, what you're describing that's a very sophisticated use of geospatial intelligence. Um, what about bringing geospatial intelligence to either industries or companies that are not using it yet, or maybe not using it to the fullest extent? How do you think about that? And what are some of the challenges to adoption that you're trying to solve for customers?
Yeah, we're thinking about that a lot. We're trying to figure out, okay, where can imagery be? Where can imagery be useful where it hasn't been before? And a lot of it's not for lack of imagination of the use case as much as it is the the types of imagery that would be required for certain sophisticated use cases, as far as like imagery that's very high resolution and happens a lot. It has a high temporal resolution, and then getting down to like cost. So how even if you have those two factors, if you have a very high resolution and a high temporal cadence, can you meet the cost needs of markets that aren't considering imagery right now? So we're excited to see the sources starting to come online. We're starting to see people experimenting with very low Earth orbit, which is creating resolutions that might meet new use cases, and also potentially putting multiple sensors up there so they can get the temporal revisit. And some of these in novel startups that could potentially have different business models, and instead of business models where scenes are very expensive, it's just kind of a stream of information that comes in that you pay for, that you can use to power applications. And I think your ultimate question is, what are those applications? And I think that there's a temptation to try to put a consumer lens on it, because that could be, but that is the ultimate goal, because that's the big, huge, wide market. But I think before we get there at Esri, we really want to empower as many enterprise users as we can with expanding their use cases, and this, getting into business analytics, and making imagery a critical part of people who are making critical business decisions, making the GIS system with imagery in it as key to a business is something, say, like SAP or Salesforce, where it's bringing a location component that has imagery power in it, which they use to derive the essential elements of a location that drive business decisions. That, I think, is the key thing. And that could be just, like that other example, like supply chain, but it could also be like object management, or object, but inventory management that they can detect with objects. Or it could be like monitoring of their critical infrastructure, such as a pipeline monitoring with the utilities or other natural resource companies, and or forestry companies that really want to refine their forest management down to almost the tree and species level, instead of just kind of a gross level. So we see a lot of expansion in just introducing imagery into those types of industries, which either did it by hand or did it with people in the field. But also, I would like to see, and I think there's an opportunity to bring imagery more into the area of like disaster preparation. As natural disasters seem to become more prevalent, can imagery be built into systems that are preparing for them? Imagery is always going to be at the response level. It's
Right.
been there for a while, and there's been a lot of evolution and a lot of technology that has made the information available in response quicker, faster, and better. But where I think there is a lot more that can be done is preparation, preparing people for disasters, giving them as much warning as they can, or at least saying this is at least identifying the risk and mitigation strategies. So I'd love to see that with come into
Yeah.
use people use GIS because that is a location problem, and GIS is solves location problems.
Yeah, I could see that having been in the Texas flood tragedies of just a few weeks ago. I
Yeah.
could see that um, imagery planning could have maybe could have contributed to having different plans in that case.
Yeah, at least identification
Mhm.
of things like the buildings, right?
Right.
Just the
Yeah.
buildings that could be affected by. I mean, flood models are out there, but imagery can give you an up to date assessment of the buildings and their potential impacts. So at least if a flood warning comes, these are the places where you need to really hyper alert or go in and get and whatever, because imagery can have that up to date picture, which can
Mhm.
then information can be extracted from.
Yeah. I liked what you said earlier about you like imagery to be as essential as Salesforce, that it's a platform that
Yes.
people are using
Yes.
to enable their businesses every day. I think that's such an interesting idea.
Yeah, I think it has potential. I mean, I mean, there's so much information in an image that businesses and governments could use almost like they use customer data in Salesforce or they use product data in SAP or other essential systems. And just getting them to think about, how imagery is just something that's always on and always available, almost like an IoT type sensor. You don't think of imagery as like an IoT sensor because an IoT sensor always is there and always is reporting. And we're quickly going to get to a point where imagery is like that. It's the remotely sensed imagery. So if imagery is always going to be available, what can we do with it? What type of signals and sensing and identification can we get off of that almost on demand?
Yeah, that's a really interesting idea.
Mhm.
When when people are using Esri ArcGIS, do they know necessarily that they're getting imagery from that they're using planet imagery versus Maxar imagery, or if it's a NASA satellite? Is that how does are people making those decisions in the platform?
Um, they are yes and no. I mean, so we the first entry point to imagery for a lot of our users is open government data source that we we exert a lot of effort in kind of harvesting and making available to our users for free because it is free data. But we kind of bring it all together and we make it available through a part of our system called the Living Atlas. So the Living Atlas is just a repository of petabytes of data, both imagery and other forms that are available to every ArcGIS user. Now, in the Living Atlas is the Landsat data, Sentinel data, NAPE data. These are all open government sources from uh, various government agencies globally. Now, it's all there and available, but the user does have to make a conscious choice that I want to use Landsat or I want to use Sentinel. And if they do, it's there and it's easy to find. It's easy to find your area and your date of interest and bring it in. So there is that. Now, the other thing, one of the things the Living Atlas also provides is our only commercial data source, which is free, which is our base map. Our base map is a collection of data sources, but primarily one that's sourced by Maxar. And so that is that's commercial data coming into the platform. And a lot of our customers don't necessarily know the source at that point. They just know that they're looking at a picture, a contextual picture that has a 30 centimeter resolution. And some of the customers don't even know what that means or care. They just know in it, I can see a car or I
Hmm.
can see markings on a road. Whereas if I bring in Landsat, I can't see those with as much clarity. So that's the entry point to commercial imagery and most of our customers do not know what the source is of that. Now, when it goes to that dynamic use case where you want to bring imagery into the platform and do something more with it, more up-to-date imagery or more dynamic information, they do have to know. We have some tools that guide them. The Skywatch tools that bring content, that broker the content, try to break it down into things like high resolution, very high resolution. And so they have to know I need a high resolution or a very high resolution, and they have to know I need a multispectral versus just a panchromatic image. So we're gradually lowering the amount of knowledge you need to know, but you still have to have some background knowledge of what you want to bring in. Yeah.
What changes in the commercial satellite imagery market are you following? Whether that's new types of sensors being launched or new business models, what are you most interested in right now?
There's a couple things I'm really interested in. I mean, the one thing that really I think is really exciting is this concept of very low Earth orbit, or
Okay.
VLEO.
Hmm.
When you're in VLEO, you're closer to the Earth. You're in space, but you're closer to the Earth. So it's just like any other camera. The closer you pull it in, the bigger the picture gets. So you have the ability to get a higher resolution picture from VLEO. Now, VLEO has tremendous challenges, like for those commercial providers, as far as operating in that space. But I'm excited that some of the newer players that are experimenting with that orbit are overcoming those challenges, are now going to produce very high resolution imagery that can power class of workflows that we can't right now, or that we can only do with aerial data or drone data, which, aerial data, it's expensive to fly. It doesn't fly all the time. Drone data, you have to physically be there. With satellites, you do not have to physically be there to get the data. You just ask the satellite for the data. So I'm really, really excited about VLEO. I'm also excited about the opportunity, or the technology evolution that some of these commercial providers are talking about, of on-orbit processing, actually not delivering a whole image down, but doing some initial processing and delivering maybe an answer powered by an AI model or something that you push up to the satellite, so that the workflow that we've always used, which was like satellite takes picture, satellite waits to find ground station to power the download, then user has to get the whole image and user has to do something with, gets cut off significantly with user says, I'm interested in this, and the satellite says, I know how to do that. I'm going to take a picture and send that down. And that could be objects of interest. It could also just be change, where a satellite just triggers and says, the last time I passed over this, I looked at the image I took and I just did a change detection and I found change. Are you interested in that? I'll just send you something that says yes or no. Obviously, much easier to do a yes or no sending down from satellite than a whole image. So I'm excited about the possibilities there and how the market could shape what commercial providers are doing on orbit. What type of information would have value to come down immediately. So those are kind of the technology things I'm interested in. I am also interested on the business side of people who are experimenting or talking about subscription models to data that are always on, that are like, I'm going to pay a cost and I'm going to get the data that I need, regardless of whether or not I need a ton of data or no data. I'm just paying for access to the feed. Now, that's a certain type of commercial sensor too that's always collecting, like Planet and some others that will eventually come online. But I think that could lower the barrier of entry of application developers building apps and things that could power it, because they don't have to worry about pricing models and stuff. They just they have a model that they pay for access, or your
Right.
users pay for access and they just get what they need.
Yeah, the
So
simulations.
yeah, so
Yeah.
and just in general, evolving licensing models that are encouraging widespread adoption.
Mhm.
I'm excited to see some people, like Umbra, exploring those as business models.
Yeah. You mentioned the on-orbit processing and the idea of
Mhm.
sending smaller pieces of data down instead of sending the whole image down. What do you think about optical communications and being able to send down large amounts of data much easier?
I think, I think that if you need the whole image,
Uh-huh.
if you need the whole image or the image, that whole image has value, or you're just gonna you really buy into that traditional model. Those optical communications, whether or not they're sat to sat or sat to ground, are super exciting because they're super fast and they just reduce that latency. Latency has always been a problem in our industry of how long does it take to get an image down? And optical, sat to sat communications that can just go boom, 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 and then down to you with seconds or minutes of latency are pretty exciting. They're very exciting. Because a lot of the times that small piece of information that the satellite can detect on orbit really will make you say, well, I need the whole thing. I need to see the whole picture.
Mm.
So you think about change or you think about an object of interest. You're like, well, wait a minute. If that object is seen, I need to see the whole scene because I need the whole picture. So in that case, give me the picture as fast as you can. And optical communications will enable that. So pretty excited about that. I know
Yeah.
that, that there are certain customer sets that are building that demand that for things, the geo end user. But the whole industry can benefit.
Yeah, cool. I was just curious what your thoughts were.
Mhm.
You've been in the remote sensing industry for quite a long time, where you were at Digital Globe in the past.
I was Digital Globe and Maxar, and then prior to that, I was with
Yeah.
a various amount of companies that exploited remote sensing. So it's
hmm
been 30 plus years.
Yeah, I mean, I don't really have a question here, but you've seen a lot of changes in the industry in that 30 years, I'm sure.
I have. I'll just tell you that when the first remotely sensed image that I processed was on a tape. Okay, so so it was a tape. You had to request that it get mounted, and then the data would come down, and so that was like a day later. So obviously the biggest change has been the availability, both, and that scene was from a U.S. government sensor. It was highly restricted to U.S. government users or educational users. So it kind of encapsulates a lot of the big changes. Is that you not only had we've gone from that access mode to like always on subscriptions or almost instantaneous data that as soon as it comes down from the satellite, it's almost available these days. To also the use profiles. When I started, I was working at NASA, so I had access because I was a NASA contractor. So I was able to get the access. Now, if you were a commercial user and you wanted that same data, it was either just not available to you or very expensive. So those same data sources, Landsat and Sentinel, are available for free in the cloud right now, which means shortly after they're collected, they're put in the cloud, and anybody can almost just get in and access them as long as they have cloud accounts. So that expanded the market. So we the big change has been it's gone from just researchers, government agencies, to now it is possible for these commercial private sector workflows for this enterprise. It's available. It's expanded. That's been that's been the big change, and there's been small changes in the middle of we moved from the tape to the web to the disks to the cloud to so on and so forth, but that's all been along those lines of making data more accessible to more people.
The tape. Wow. That's that's
Oh,
that's
it's fun. They used to stick together too. The tape would actually get sticky and then you'd lose your data. Yeah.
Oh man. And just like you said, the amount of time that it would take to get a piece of information, so much time, so many steps involved there. I mean, yeah, that's really amazing. The speed, like the speed that things are possible now, and like you
Yeah.
said, the
Yep.
expanded access that's possible.
Well, and the lowering of the barrier of entry to actually exploit imagery as well. It did used to take an image scientist or a spectral scientist or an engineer who really could understand the concepts of digital imaging and sensors to understand it, to actually get more from these data than just the picture.
Hmm.
Because the promise is it's more than just a picture. You're going beyond just that contextual base map. You're trying to derive what other pieces of information. And it was a high barrier of entry to get in. That barrier of entry is lowered significantly with a set of tools that have come out over the years, but then now AI is really lowering it down because you're telling the computer to act like you are, and if you can
Hmm.
see it, you can extract it, and that's one of the early promises of computer vision based AI. Whereas before you would have to know the science and get into the actual numbers down there to pull it out.
Yeah. Do you have any concerns about the computer vision based AI? Like, I, it, one of the things I've been thinking of is if open source models can do this sort of exploitation, then why would someone need to go to, and I'm sure they'll charge for it, but it just kind of made me wonder if it could become so democratized that we don't even need specialized um, companies that work with imagery anymore. And that might be years away. That might not make any sense. It's just something I thought of.
I mean, there's always going to be a concern that that I mean, first of all, somebody's got to build these sensors. So somebody's got to build and operate the sensors. So they're going to be around. Now, as far as extracting the information, yes, I mean the computer vision based models, as they improve their accuracy, and as we get more comfortable with the results that are coming out, there could be potentially be a situation where we're not in the loop. In fact, the agentic AI that I'm talking about earlier, that's really exciting, but that in a lot of cases does take the human out of the loop. That's where the agents are not only determining what imagery to use, they're assisting in the search and discovery of the data. Then they're actually using the data and they're determining what models or algorithms need to be exploited. Then there's with those results, they're just saying, and this is I where I should put it, and this is the decision I make off of that. In that case, the only human in the loop is maybe double checking the math and the
Hmm.
answer. So I think there's always going to be a place for somebody to build those agents and determine how those agents interact. So maybe we evolve into just monitoring the agents, building the agents, updating the agents, and improving them. But yeah, no, it's a bigger concern that if you're skilled in traditional imagery
Hmm.
manipulation and pixel exploitation, that the computer vision could take some of that out. But I think there's also, though, a lot more research that needs to be done just in that domain and that space. So there's I don't think that'll ever go away is the
Hmm.
research on the sensor and the sensors have to be built.
Yeah.
Yeah.
Yeah. I appreciate your thoughts on that. That was something I was
Hmm.
curious about. Well, this has been such an interesting conversation. Really appreciate you letting me kind of pick your brain on all this stuff. Um, any final thoughts as we close out?
Um, I mean, my final thought is that at Esri we're really excited about the possibilities with imaging or remote sensing content within GIS workflows and mission focused systems. And we're hoping that the user base that we have, which is a good sized user base, that we can turn them on to these sources so that we can be a part of keeping this ecosystem healthy and growing, the ecosystem of commercial data access and commercial data providing and access. Um, because there is always a risk that the industry builds beautiful satellites and sensors and that they're not necessarily used to their full potential. And we're hoping that by exposing them to a larger market, we can realize as much of that potential as we can and keep this industry healthy and growing. That motivates me and drives me to push this technology out to as many people as I can.
Yeah, and that is a great point. And that's one of the challenges that I've watched the satellite imagery industry grapple with, is bringing it to new users, because there are so many different applications, but actually reaching those new enterprises, new industries. So it's great to hear from you about how Esri is working alongside to do that. Beau, thank you so much. It was great to talk with you.
Absolutely great to talk to you, Rachel, and I appreciate your interest in this and the conversation.